Hello, everyone. Today we are going to talk about cognitive architecture, basically agent building using generative AI. And we are going to talk about building custom agents. We're going to talk about human in loop at multiple levels for tool selection, for success criteria for every iteration, for example. And then, of course, we will be talking about multi-agent framework. We are using the LangChain and the LangGraph. It's one of my favorite go-to libraries. Um, my name is Jamin, and I have Ayush with me. And we are going to talk about multiple templates. So plan and execute template, critique, react, self, ask, and multi-agent. These are all available in the library. And the starter point, if we go to the resources for the agents in the Python, so this is the place from where you can start and have the first level of starter package codes, which then of course you can manipulate and take it ahead. So with that as a context, I think Ayush, let's start with the first agent approach where we are not going to have any human in loop. It's a simple agent where we give task and it runs tools non-heuristically.
Okay, so for the demo purpose, we'll start my agent. Provide a simple query to my agent. So we'll provide two.
A-N.
Search. In background, it is executing, it is using a particular tool for this particular query and executing and computation provide a final response. We see in the UI. Our agent uses a search tool, as an internet search tool. It goes to internet and search for the new findings in quantum computing and provide a final response. So with the response, there are some latest findings in quantum computing, new growth direction, graphene stick domains, and these are some response it got from the internet. Now we can proceed with another demo.
Okay. So here what happened is why it is a cognitive architecture. Search is one of the tools we gave, including some other custom tools. And based on the query from the user, the agent understood which is the best tool to apply to get the response. It could also apply multiple tools. For example, in here, we just used a SERP API, and from there, it gets the data and then scrapes the information and then feeds it to LLM, makes it readable, gives it back to us, right? Now, the factor really is that when we have multiple agents, how do we make sure that we bring a human in loop so that for every step that the agent wants to perform, it confirms the input to the tool from a user, right? So that is what we will try to do as the next step.
So for next agent, we have a workflow. Like we have added another node. It's a human review node. What human review node do? Before calling any tool, before using any tool, our agent will ask us like if this is the correct output or input for the from the tool. So let's start the demonstration. I have to change some code changes. Some code.
Bring the HTML content and we change the graph nodes to bring a conditional edge and a node, right? So we bring the human in review node into the graph and then
Comment out this one for the normal. Now we have added a human in review as a conditional edge for every tool call.
so let's start with a query on research on quantum mechanics, for example.
So So it is like it is asking us like this is correct. So it is a quantum mechanics. It is using a search tool, searching for internet. So what it gives to our search tool is quantum mechanics.
Okay. So let's say that this input is not right. We want to validate, change it a little bit. So let's change it to quantum mechanics in factory automation.
So we can change the tool input like this, copy the input and change it to tool mechanics
in factory automation. This is the human in loop where the agent is actually now having a conversation with human in loop to see what are the changes that we may want to do.
All right. Now we have to
update. And now again, the agent is doing the same thing. It's figuring out the tools and running it and giving me the response.
So now again, it uses search tool now, but the tool input is changed. Now tool input is quantum mechanics in factory automation. Right. Before it was only quantum mechanics. Okay. So it got some response from internet. Now it gives some response. The quantum mechanics combined with AI can significantly enhance the factory automation. It can provide valuable insights into processing,
scheduling and optimization problems, right? Okay. So what we did so far is that if there were the problem complication was bigger, then now it would have gone to another tool, and for every tool, the next step, it would have waited and asked the human if the input is right or wrong, right? So that is a multi-step, multi-task breakdown. For every task performing, the agent will stop and bring the human in loop to make sure that the input going to the task is the right one, right? Now we want to do the changes in such a way that not only does the input change, but am I satisfied with the output? Otherwise, I would want to give it feedback and make it continue performing the work. So now let's try and bring the human in loop at the output level to check the confidence of the output from a human. Now, this can also happen at every task that it performs, right?
Right.
So let's go to that step.
So for that, I have to change some code changes. So there's a basic workflow to how we can, the alternative way how we can achieve this. So before ending the agent execution, is happy node is added. So what is happy node is doing, it is asking the user if you are happy with the final response. So if users choose yes, then it will terminate itself. If user choose no, then you have to provide some additional information, and according to that information, it will alter your response. Okay, so to run this startup.
You will have to change the HTML to bring those nodes in. Yes. And no changes in the Python. We have that node already. But okay, good. So let's start. Let's rectify the spelling of mechanics, CHA. Yeah. And yeah. Then run the graph. So now, again, it will ask me if this is correct. This time I will say, again, the same thing. I'll say, no, I want to have quantum mechanics in factory automation. So let's select the args and change it. Of course, the UI can be end user UI when we really want to do, but this is just for demonstration purposes. Okay, update. Sorry. Okay. And now it's performing in the background. It's thinking about the task it has to do. It figure out the tool and gives our new input. If we have clicked on update, it'll give the new input, and then it'll give hopefully the outcome. Let's look on the console if the things are proceeding or if there is an error. There's an error.
I will run this statement again.
Okay. Okay. Just say update. Yes. So now the outcome came, and we got the outcome like last time. But if you see the last question, I'm being asked now, am I happy or not? So I will say no, I'm not happy. right? And the input I would want to change the construct to in factory automation for quality inspection. So I want to specifically target quality inspection use cases.
Provide the same.
Okay, and I submit. And now I have human in loop at every task breakdown for even checking the outcome or the success criteria that happens.
Okay, now change the tool input. Like now it is searching for quantum mechanics and factory automation for quality inspection.
Nice.
Now it takes the user input. Now I will say continue.
Yeah.
So this is correct.
Right.
Continue, provide some response. This is the response it is getting get from the internet.
Perfect. Perfect. So enhanced computational power, quantum computing can process vast amounts of data from sensors at every stage in manufacturing processes for real-time quality and precision, etc. Right. So now it brings into the context, does it research and gives me back based on the tools that I have given. So these are the three levels of agentic approach or cognitive architecture approach. One, give it the tools, let it identify and perform its job. Second, break down the task for every task. Check with the human if it is doing the right input for right tools. So we can change the input or the tool. And the last stage would be also the success criteria of every task. We can have a human in loop and we say, I need to change a little more. I'm not happy. Before you continue doing the further work, change this task that you're performing meanwhile before picking up the next task, if there is a bigger complicated statement, right? So this would be the overall agentic approach with human in loop at two levels, tools and success criteria.